Hello everyone, welcome to Simplilearn's YouTube channel. In this full session, we will learn about Puppet, Chef, and Ansible from scratch, right from their installation to a full-fledged use case. We will begin the session with the comparison between Chef, Puppet, Ansible, and SaltStack. Followed by that, we will learn what is Chef. Then, we will learn the installation of Chef in our local system. Once the fundamentals are done, then we will start with a complete tutorial where you can learn Chef with us with the perfect hands-on experience. Next, in the same way, we will get started with Puppet. And lastly, we will have Ansible in the stack. And finally, we will wind up the session with the most frequently asked interview questions to make sure that you're on the safer side during your interviews. So, I hope I made myself clear with the agenda. But before we begin, make sure that you have subscribed to our YouTube channel and don't forget to hit that bell icon to never miss an update from Simplilearn. So without further ado, let's get started.
Hello, this is Matthew with Simplilearn, and today we're going to go through a real tough battle. We're going to decide which is better for your operations environment. Is it Chef, Puppet, Ansible, or SaltStack? All four are going to go head to head. So let's go through the scenario of why you'd want to use these tools. So let's meet Tim. He's our system administrator, and Tim is a happy camper putting and working on all of the systems in his network. But what happens if a system fails? If there's a fire, a server goes down? Well, Tim knows exactly what to do. He can fix that fire really easily. The problems become really difficult for Tim, however, if multiple servers start failing, particularly when you have large and expanding networks. So this is why Tim really needs to have a configuration management tool, and we need to now decide what would be the best tool for him, because configuration management tools can help make Tim look like a superstar. All he has to do is configure the right codes that allows him to push out the instructions on how to set up each of the servers quickly, effectively, and at scale. All right, let's go through the tools and see which ones we can use. The tools that we're going to go through are Chef, Puppet, Ansible, and SaltStack. And we have videos on most of these software and services that you can go and view to get an overview or a deep dive in how those products work. So let's go and get to know our contestants. So our first contestant is Chef. And Chef is a tool that allows you to configure very large environments. It allows you to scale very effectively across your entire ecosystem and infrastructure. Chef is by default an open source code. And one of the things that you find is a consistent metaphor for the tools that we recommend on Simplilearn is to use open source code. The code itself is actually written in language of Ruby and Erlang. And it's really designed for heterogeneous infrastructures that are looking for a mature solution. The way that Chef works is that you write recipes that are compiled into cookbooks, and those cookbooks are the definition of how you would set up a node. And a node is a selection of servers that you have configured in a specific way. So for instance, you may have Apache Linux servers running, or you may have a MySQL server running, or you may have a Python server running. And Chef is able to communicate back and forth between the nodes to understand what nodes are being impacted and need to have instructions sent out to them to correct that impact. You can also send instructions from the server to the nodes to make a significant update or a minor update. So there's great communication going back and forth. If we look at the pros and cons, the pros for Chef is that there is a significant following for Chef, and that has resulted in a very large collection of recipes that allow you to be able to quickly stand up environments. There's no need for you to have to learn complex recipes. The first thing you should do is go out and find the recipes that are available. It integrates with Git really well and provides for really good, strong version control. Some of the cons, though, are really around the learning speed it takes to go from beginner user with Chef to being an expert. There is a considerable amount of learning that has to take place, and it's compounded by having to learn Ruby as the programming language. And the main server itself doesn't really have a whole lot of control. It's really dependent on the communication throughout the whole network. All right, let's look at our second contender, Puppet. And Puppet is actually in many ways very similar to Chef. There are some differences, but again, Puppet is designed to be able to support very large heterogeneous organization. It is also built with Ruby and uses DSL for writing manifests. So there are some strong similarities here to Chef. As with a Chef, there is a master-slave infrastructure with Puppet, and you have a master server that has the manifests that you put together in a single catalog. And those catalogs are then pushed out to the clients over an SSL connection. Some of the pros with Puppet is that, as with Chef, there is a really strong community around Puppet, and there's just a great amount of information and support that you can get right out of the gate. It is a very well developed reporting mechanism that makes it easier for you as an administrator to be able to understand your infrastructure. One of the cons is that you have to really be good at learning Ruby again, as with Chef. The more advanced tasks really need to have those Ruby skills. And as with Chef, the server also doesn't have much control. So let's look at our third contender here, Ansible. And so Ansible is slightly different. It is, the way that Ansible works is that it actually just pushes out the instructions to the server environment. There isn't a client server or master slave environment where Ansible would be communicating backwards and forwards with its infrastructure. It is merely going to push that instructions out. The good news is that the instructions are written in YAML, and YAML stands for YAML Ain't Markup Language. YAML is actually pretty easy to learn. If you know XML, and XML is pretty easy, if you know XML, you're going to get YAML really well. Ansible does work very well on environments where the focus is getting servers up and running really fast. It's very, very responsive and can allow you to move quickly to get your infrastructure up very fast. And we're talking seconds and minutes here, really, really quick. So again, the way that Ansible works is that you put together a playbook and an inventory, or you have a playbook. So the way that Ansible works is that you have a playbook, and the playbook, it then goes against the inventory of servers and will push out the instructions for that playbook to those servers. So some of the pros that we have for Ansible: we don't need to have an agent installed on the remote nodes and servers. It makes it easier for the configuration. YAML is really easy to learn. You can get up to speed and get very proficient with YAML quickly. The actual performance, once you actually have your infrastructure up and running, is less than other tools that we have on our list. Now, I do have to add a proviso. This is a relative less. It's still very fast. It's going to be a lot faster than individuals manually standing up servers, but it's just not as fast as some of the other tools that we have on this list. And YAML itself as a language, while it's easy to learn, it's not as powerful as Ruby. Ruby will allow you to do things that at an advanced level that you can't do easily with YAML. So let's look at our final contender here, SaltStack. So SaltStack is a CLI-based tool. It means that you will have to get your command line tools out or your terminal window out so you can actually manage the entire environment via SaltStack. The instructions themselves are based on Python, but you can actually write them in YAML or DSL, which is really convenient. And as a product, it's really designed for environments that want to scale quickly and be very resilient. The way that SaltStack works is that you have a master environment that pushes out the instructions to what they call grains, which is your network. And so let's step through some of the pros and cons that we have here with SaltStack. So SaltStack is very easy to use once it's up and running. It has a really good reporting mechanism that makes your job as an operator in your DevOps environment much, much easier. The actual setup, though, is a little bit tougher than some of the other tools, and it's getting easier with the newer releases, but it's just a little bit tougher. And related to that is that SaltStack is fairly late in the game when it comes to actually having a graphical user interface for being able to create and manage your environment. Other tools such as Ansible have actually had a UI environment for quite some time. All right, so we've gone through all four tools. Let's see how they all stack up next to each other. So let the race begin. Let's start with the first stage, architecture. So the architecture for most of our environments is a server-client environment. So for Chef, Puppet, and SaltStack. So very similar architecture there. The one exception is Ansible, which is a client-only solution. So you're pushing out the instructions from a server and pushing them out into your network, and there isn't a client environment. There isn't a two-way communication back to that main client for what's actually happening in your network. So let's talk about the next stage, ease of setup. So if we look at the 4 tools, there is one tool that really stands out for ease of setup, and that is Ansible. It is going to be the easiest tool for you to set up. And if you're new to having these types of tools in your environment, you may want to start with Ansible just to try out and see how easy it is to create automated configuration before looking at other tools. Now, and so with that said, Chef, Puppet, and SaltStack aren't that hard to set up either. And you'll find there's actually some great instructions on how to do that setup in the online community. Let's talk about the languages that you can use in your configuration. So we have 2 different types of language, with both Chef and Ansible being procedural, in that they actually specify at how you're actually supposed to do the task in your instructions. With Puppet and SaltStack, it's decorative, where you specify only what to do in the instructions. Let's talk about scalability. Which tools scale the most effectively? And as you can imagine, all of these tools are designed for scalability. That is the driver for these kind of tools. You want them to be able to scale to massive organizations. What do the management tools look like for our 4 contenders? So again, we have a 2-way split. With Ansible and SaltStack, the management tools are really easy to use. You're going to love using them. They're just fantastic to use. With Puppet and Chef, the management tools are much harder to learn, and they do require that you learn some either the Puppet DSL or the Ruby DSL to be able to be a true master in that environment. But what does interoperability look like? Again, as you'd imagine, with the similar to scalability, interoperability with these products is very high in all 4 cases. Now, let's talk about cloud availability. This is increasingly becoming more important for organizations as they move rapidly onto cloud services. Well, both Ansible and SaltStack have a big fail here. Neither of them are available in the most popular cloud environments. And Puppet and Chef are actually available in both Amazon and Azure. We've actually just haven't had a chance to update our Chef link here, but Chef is now available on Azure as well as Amazon. So what does communication look like with all of our 4 tools? So the communication is slightly different with them. Chef has its own knife tool, whereas Puppet uses SSL, so Secure Sockets Layer, and Ansible and SaltStack use Secure Socket Hashing, SSH, as their communication tool. Bottom line, all 4 tools are very secure in their communication. So who wins? Well, here's the reality. All 4 tools are very good, and it's really dependent on your capabilities and the type of environment that you're looking to manage that will determine which of these 4 tools you should use. The tools themselves are open source, so go out and experiment with them. There's a lot of videos. Our team has done a ton of videos on these tools, and so feel free to find out other tools that we have and covered so you can learn very quickly how to use them. But consider the requirements that you have and consider the capabilities of your team. If you have Ruby developers or you have someone on your team that knows Ruby, your ability to choose a broader set of tools becomes much more interesting. If, however, you're new to coding, then you may want to consider YAML-based tools. Again, the final answer is going to be up to you, and we'll be really interested on what your decision is. Please post in the comments below which tool you have decided to go with and what are the challenges that you're coming up with, because we'll help answer those challenges for you. Today, we're looking at how we can use Chef to improve the way that you administer hardware within your DevOps environment. There's going to be 6 things that we're going to step through. The first is really looking at what is the world that many of you already work in today. How do you administer your networks and your systems today? Then we're going to look at how Chef can be the tool that really helps improve the efficiencies of creating a consistent operations environment. We're going to look at the tools and the components and the architecture that it takes to construct Chef. And then finally, we're going to take a use case of one of the many companies that is using Chef today to improve the efficiency of their operations environment. So let's take a step back at what life was like before Chef. This may well be the life that you're experiencing right now. So as a system administrator, typically the way that you work is that you are responsible for the uptime of all of the systems within your network. And you may have many systems that you are responsible for. Now, if one system goes down, that's not a problem, because as a system administrator, you can get notifications and you can jump right onto the problem and solve it. When things start getting really difficult, however, is when you have multiple systems and you are not able as a single person to get to all those systems and solve them as quickly as possible. The problem that you start having is that your environments are not in sync. If only this could all be automated. Well, this is where Chef comes to the rescue for you. So let me take some time and introduce you to the concepts behind Chef and why it's a tool that you would probably want to be using in your environment. So what actually is Chef? So Chef is a way in which you can use code to fix your physical hardware environment. So what does that look like? Well, the way that we write out scripts in Chef is that you can actually code your entire environment. So you don't have to actually be managing your environment on a hardware by hardware basis, but actually use scripts called recipes that will actually manage the environment for you. So Chef will actually ensure that every system is automatically set to the right states that meet the requirements that you have defined in your code. So you don't have any issues where hardware starts to fail, because it references the code to reset the state within that environment. And that makes you a happy system administrator. So let's go through the mechanics of how this actually works with Chef. So Chef is ultimately an automation tool that converts infrastructure to code. And you'll often hear the term infrastructure as code, or IAC. And this really starts as an output of the work that Chef has done. Because you take the policies that you as an organization have created and you convert that into a scripted language that can then be implemented automatically. This enables Chef to be able to manage multiple systems very easily. And considering how broad and deep our systems become, it's very easy to see how this can help you as a system administrator. The code is then tested continuously and deployed by Chef so that you're able to guarantee that your standards and appropriate states for your hardware and operating environment are always maintained. So let's step through the different components that are available in Chef. So the first one is actually creating the actual recipes for Chef. So you actually work on these on a workstation and you'll write out your code, which is referred to as a recipe. And that recipe will be written using a language called Ruby. Good thing for you is that there are lots of examples of Ruby recipes that have been created by the open source community. A lot of examples. Knife is the command tool that you use that communicates between the recipes and the server. So your recipe is the instruction and Knife is the tool that makes that instruction work and sets the appropriate state on the server environment. When you create more than one recipe, you start creating a collection. Those collections are referred to as cookbooks. And you may take an environment such as a large network where you have multiple nodes, potentially hundreds of servers, that have to all have a consistent and equal state environment. And you would put that cookbook and use that cookbook to ensure with Chef that the state of each of those nodes is consistent. And then Ohai fetches the current state of your nodes, and then the Chef client configures the nodes as defined within your cookbook. So let's step through the architecture and working environment of Chef. So for an administrator, a systems administrator, you only have to now work from your workstation. And from that workstation, you can then configure all the nodes of your environment.
You can use different recipes that you create, and those recipes can be compiled into a cookbook that can be then applied to a node. The thing that's of value is that as you change the environment, as you move and mature as an organization, and your nodes need to mature consistently and quickly with your organization, all you have to do is roll out a different recipe to your nodes, and then the nodes will use the tools within Chef to make the updates. So you can create a second recipe or even a third recipe to be deployed out to your server environment. Knife is going to be the tool that does the hard work of doing the updates on the server. With the server, you have your collection of recipes in a single cookbook. However, understanding the state of the individual nodes is important to ensure that the information is broadcast from the server with the instructions on how to set up the network within those nodes. In this instance, we use OHI, and OHI will fetch the state of the nodes and send that back to the server and get the information from the cookbook using the Chef client. In your Chef node network, there is the potential at times that maybe one of your node fails. If there are two failed nodes, then a request is sent back to the server, and information on the latest node structure that is identified and defined in the cookbook will be sent to the failed nodes. If that fails to reset the nodes, then the workstation is notified, and you as the administrator will receive a notification to manually reset those nodes. It should be noted that this is a very rare occasion within the Chef network setup. So let's step through a use case. In this instance, we're going to look at Hapoalim and how they used Chef. So Hapoalim is a bank, and it's the largest bank in Israel. And they have a mixture of Linux and Windows servers that they have to maintain. And as you can imagine, this requires a lot of constant configuration and work, and this has led to issues in the past. So the challenge that the team at Hapoalim faced was creating and hardening software that ran the major tasks and was repeatable on those servers, that it didn't matter who the people were performing the jobs, that there was consistency in the work that was being done, and address the problem that the servers, including the hardware on the servers, was not consistent throughout the organization. Chef addresses those specific problems and became the go-to product for Hapoalim. They were able to write the recipes and the cookbooks that could be deployed out to the network effectively. And it didn't matter what the system was, the recipes reflected the standards that the system administration team put together. And they were able to ensure and test each script and use standard testing tools for those scripts. It didn't matter what kind of environment that Hapoalim had, if certain ports need to be closed, or if a firewall needs to be installed or modified, or if custom strong passwords had to be created. All of this could be done using the recipes that Chef offers. And once those recipes had been finalized, they could be packaged into a common cookbook that could then be deployed to the entire network, ensuring a consistency in results for the company. And also, it didn't matter whether the cookbooks were being deployed to Linux or Windows machine, because the scripts were being put together in the recipes and were written in Ruby. You could actually go through and update and modify those scripts depending on the environment. So if you needed to make a modification for Linux, you could make those modifications so they were consistent across all the Linux servers or all the Windows servers. And this really drove in the ability to harden and secure the environment in the entire network within a matter of minutes using Chef versus the days and weeks that it previously took. So if we take a before and after scenario using Chef, before Chef, tasks were repeated multiple times, and it was just hard to keep track of all the people doing the work. And the reality is, because so many people were touching all the different systems, specific standards that the banks had established were simply not being met. After Chef, all of the tasks could be scripted using Ruby. And using the recipe and cookbook model that Chef has created, the Chef tool was able to deploy out to the entire network specific cookbooks that provided a consistent experience and consistent setup and operation environment for all the hardware. The end result is that the system administration team could guarantee that the standards of the bank were being met consistently. So just the takeaways that we have here of Chef. So life before Chef is complicated. If one server goes down, you can probably get it back up and running. But if you are working in a modern system administration environment, you have many systems, and if multiple systems start going down or having failure points, it is difficult to identify where those failure points are and how to solve them. Chef resolves this issue, and it does so by turning the environment that you're managing with hardware and software into code. And once you have it written as code, you're able to then test that code. Chef itself is made up of a number of key components. As a system administrator, you work on your desktop at your workstation and you create recipes. Those recipes are then bundled together into a cookbook. And that cookbook communicates with the server, the main Chef server, and the node of servers within your environment. And Knife is the tool that does that communication. Ohai and the Chef client on the various node servers will communicate back to the Chef server what the standards and the environment are, so that they can provide a two-way communication to validate that the system has been set up and is being maintained to the same standards as defined by the individual recipes. As an architect and working in this Chef environment, it makes it much easier for you to be able to control the entire system administration. Instead of having many people having to work on all the servers, you can now have one person controlling hundreds of servers simultaneously. And Hapoalim have been able to prove conclusively that Chef is the tool that can help improve the consistent experience of working with hardware.
A very warm welcome to all our viewers. This is Anjali from Simplilearn, and today we'll be looking at the installation for the tool Chef. As you probably already know, Chef is a configuration management tool. So that basically means that Chef is a tool which can automate the entire process of configuring multiple systems. It also comes with a variety of other functionalities which you can check out in our video on what is Chef and the Chef tutorial. So before we move on to the installation process, let me just explain to you in brief the architecture of Chef. So Chef has three components. There's the workstation, which is where the system admin sits, and he or she writes the configuration files here. Your second system is the server. The server is where all these configuration files are stored. And finally, you have the client or the node systems. So these are the systems that require the configuration. You can have any number of clients, but for our demo, to keep it simple, we'll just have one client. Now I'm using my Oracle VM VirtualBox Manager, as you can see here. I'll have two machines, the master and the node. Both of these are CentOS 7 machines. As of the server, we'll be using this as a service on the cloud. So let's begin. Let's have a look at our master system first. This is my master system. The terminal's open over here, and the terminal color here, it's black background with green text. And this is my node system. So the terminal here has a black background with white text. So you can differentiate between the both. So we start at our master system. The first thing we need to do is we need to download the Chef DK. So you can write wget, which is the command for downloading, and then go to your browser and just type Chef DK here. The first link. So here you have different versions of Chef DK. Depending on the operating system that you're using, you need to select the appropriate one. I'm using the Red Hat Enterprise version, and that's number 7. So I'm using CentOS 7. So this is my link for downloading Chef DK. Just copy this link and go back to your terminal and paste it here. So your Chef DK is being downloaded. This will take a while. Right after we download the Chef DK, our next step is to install it on our system. So our Chef DK is downloaded. Now let's install it. So guys, this is the version of Chef DK that you have downloaded. So make sure this is exactly what you type down here too. So great, our Chef DK is installed. So basically our installation for the workstation is done right now. But just so you understand how the flow is, we'll also write a sample recipe on our workstation. So before we do that, let's first create a folder. My folder name Chef Repo, basically the Chef repository. And let's move into this folder. Okay, so we're in. Next, what we need to do is, as I mentioned earlier, all your recipes will be within a cookbook. So let's create a folder which will hold all our cookbooks. And let's move into this too. Okay, so our next stage is to create the actual cookbook within which we'll have our recipe. So the command for creating the cookbook is chef generate cookbook sample. So sample is the name of my cookbook. So guys, please notice here, cookbooks is the directory that I created, which will hold all our cookbooks. And here cookbook is the keyword. So sample is that one cookbook that we are creating under our folder cookbooks. And our cookbook's being created. Great, so that's done. Moving into our cookbook. Okay, so when our cookbook sample was created, automatically there's this hierarchical structure associated with it. So let's have a look at this hierarchical structure to understand what our cookbook sample exactly is before we move on. So the command for looking at a hierarchical structure is tree. So as you see here, within our cookbook, we have a folder recipes, and under this there's the default.rb recipe. This is where we'll be creating our recipe. So we'll just alter the content of default.rb. So let's move on to finally writing our recipes. So we'll move into this recipes folder first. So now we'll open our recipe default.rb in gedit. So the recipe for this particular demo is to install the HTTPD package on our client node, that is basically your Apache server, and we'll also be hosting a very simple web page. So let's begin. So the recipes in Chef is written in Ruby. So I'll explain you the recipe in a while. Okay, so the first line is where you install HTTPD. The second line for service is where you start or enable the HTTPD service on the client node. That's our first task. The second part's where we need to create our web page. So this is the part where your web page will be stored. If you have written any HTML file previously, you know that this is probably like a default path where our web pages are created. Yep, that's it. So this is the content that will be displayed on your web page if everything works right. And I'm pretty sure it will. So now we can save our recipe, and that's done. Close your gedit. So now that we have created the recipe, all our work at the workstation is completed. The next thing we do is we move on to the server. So as I mentioned earlier, we'll be using the server as a service on the cloud. So go to your browser and here just type manage.chef.io. So this is the homepage of your Chef server. Click here to get started. We need to first create an account for using the Chef server. This is completely free. We just need to give our email ID and a few other details. It's in fact a lot like creating an account on Facebook or Instagram. Fill in all the details. Check the terms of service box. So the next thing you need to do is go back to your inbox and verify your email ID. So I have my inbox opened here on my Windows machine. So this is my inbox. You would have received a mail from Chef Software. Just click on this link to verify it and create your password. And that's done. So let's continue this on our workstation machine. So type in your username and password. So the first time you log into your Chef server, you'll have this pop-up appear where you need to create a new organization. So create your organization. So this organization is basically the name that will be associated with a collection of the client machines. First thing you do, go to your administration tab and download the starter kit. So guys, when you're doing this part, make sure that you're on your workstation. That is, you're opening your Chef server on the workstation, because you need this folder to be installed here. You save the file. So this gets downloaded. So the Chef Starter Kit is the key to connecting your workstation with the server and the server with the node. So basically it has a tool called Knife, which we'll come across later in our demo. This Knife is what takes care of all the communication and the transferring of cookbooks between the three machines. In our case, the two machines, the workstation and the node, and the one server. So let's go back to our root directory. So our Chef Starter zip file is within our downloads folder. What we do first is we'll move the zip folder into our cookbooks folder and then we'll unzip it there, because our cookbooks folder is the one that contains the recipe, and that is where we require knife tool command to be present so we can send these recipes over to the server. So we'll just check the contents of our cookbooks right now to ensure that our chefstarter.zip file is within the cookbooks. Yep, so it's here. So next thing we do is we need to unzip this folder. Great, so that's unzipped. And this means that our workstation and our server are now linked. So we just need to use the knife command tool to transfer or to upload our recipes, which we created on the workstation, onto the server. So before we execute this command, we need to move into our cookbooks directory. As you know, that is where we unzipped our Chef Starter Kit. So that is where our knife command is present too. And now let's execute the knife command. So it's knife, cookbook, upload, and sample. So as you probably recall, sample is the name of the cookbook that we created. And within sample, we created our recipe, which is default.rb. So we're uploading the entire cookbook onto the server. Execute the command. Great, so our cookbook's uploaded. Now let's check this on our server. So move to your browser where you opened your Chef server and go to policy. So here you go. This is the cookbook we uploaded sample, and it's the first time we uploaded it. So the version 0.1.0, the first version. Now what you would notice is if you go to the nodes tab, there are no nodes present. So if you have no nodes, you basically have no machine to execute your cookbooks. And the nodes are not seen right now because we have not configured them yet. So that's the next thing we need to do. All this so far was done on your master machine. Now we'll move on to the node machine. So before moving on, let's just check the IP of our node machine. So that's our IP. Note this down somewhere. And now we move back to our workstation. As we already saw that we uploaded a sample workbook, next thing we need to make sure that our server and node are able to communicate with each other. So again, we use the knife tool for this too. The command here is knife, bootstrap, and enter the IP address of your node, which we just checked. We'll be logging in there. So we'll be using the node as the root user. And then we also need to specify our root password for the node. And we give a name to this node. So this is the name by which we'll be identifying our node at the server. So as you've probably noticed here, we're using the term SSH, which is a secure shell. So it basically provides a channel of secure communication between two machines in an unsafe environment. Okay, so it's done. So if your command has executed right, which in our case, as we can see, has, our Chef server and our Chef node must be able to communicate with each other. So if this is so, we should be able to send the cookbook that we previously uploaded from our workstation onto the server, now from our server to our node. So to do that, before we move on to the node machine, we need to go back to our Chef server. Let's refresh this page. And as you see here, previously under the nodes tab, we did not have any node mentioned. Now we do. Chef node, which is the node we wanted to identify our node by, which is a CentOS platform. And that's our IP. So it's active for 2 hours. That's the uptime. Last check-in, the last time we checked into our node was a minute back. And yeah, that's pretty much it. So now we'll create a run list and we'll add our sample to this run list. So just click on your node. And you'll see the small arrow here in the end. Click on that, edit run list. And under available recipes, we have our cookbook sample present. So drag and drop this to the current run list and accept it. Okay, so now that we updated our run list, our recipe is sent to our node. What we next need to do is that we need to execute this at our node. So now we'll move on to our node machine. Chef client is the command to execute your. So while this recipe is executing, you can see what exactly is happening. Our recipe was to install HTTP package first, which is your Apache server. So the first line, that's done and it's up to date. The second line, it's enabled. Third line, the service is started. And the fourth line is where your contents created for the web page at this very location. So by the look of this, everything should work fine. So how do we check this? We can just go to our browser and in the search bar, just type localhost. And there you go. So our HTTP package, which is the Apache server, is installed and our sample web page is also hosted. If you look at the DevOps approach or the DevOps lifecycle, you will see that Chef falls under operations and deployment. So before we begin, let's have a brief look at all that you'll learn today. First, we'll get to know why should we use Chef and what exactly is the Chef. Two of the most common terms used with Chef, configuration management and infrastructure as code. We'll have a brief look at these. We'll also have a look at the components of Chef and the Chef architecture, quickly go through the various flavors of Chef, and finally we'll wrap it up with a demo on the installation of Apache on our nodes. So let's begin, guys. Why should we use Chef? Well, consider a large company. Now this company caters to a large number of clients and provides a number of services or solutions. Of course, to get all of this done, they need a huge number of servers and a huge number of systems. Basically, they will have a huge infrastructure. Now, this infrastructure needs to be continuously configured and maintained. In fact, when you're dealing with an infrastructure that size, there's a good chance systems may be failing. And in the long run, as your company expands, new systems may even get added. So what do? Well, you could say the company has the best system administrator out there, but all by himself, could he possibly take care of an infrastructure that size? No, he can't. And that's where Chef comes in, because Chef automates this entire process. So what does Chef provide? Chef provides continuous deployment. So when you look at the market space today, you see how products and their updates are coming out in a matter of days. So it's very important that a company is able to deploy their product the minute it's ready, so that once it's out, it's not already obsolete. Chef also provides increased system robustness. As we saw, Chef can automate the infrastructure. But in spite of this automation, there's a good possibility that errors do creep in. Chef can detect all these bugs and remove them before deploying them into the real environment. Not only this, Chef also adapts to the cloud. We all know how today the services, tools, solutions, everything's revolving around the cloud. So Chef does really play along by making itself easily integratable with the cloud platform. So now that you know why to use Chef, let's look at what exactly is Chef. Chef is an open source tool developed by Opscode. Of course, there are paid versions of Chef, such as Chef Enterprise, but other than that, most of it is freely accessible. Chef is written in Ruby and Erlang. If you would have gone through any previous material on Chef, I'm sure you would have come across Ruby being related to Chef, but not Erlang. So this is why, because Ruby and Erlang are both used to build Chef, but when it comes to actually writing the codes in Chef, it's just Ruby. And these are the codes that's deployed onto your multiple servers and does the automatic configuration and maintenance. And this is why Chef is a configuration management tool. So I've used this term configuration management a couple of times. What exactly does this mean? Let's start with the definition of configuration management. Configuration management is a collection of engineering practices that provides a systematic way to manage entities for efficient deployment. So let's break this down. Configuration management basically is a collection of practices. And what are these practices for? These practices are for managing your entities, the entities which are required for efficient deployment. So what are these entities that you need for efficient deployment? They are code, infrastructure, and people. Code is basically the code the system administrators write for configuring your various systems. Infrastructure is the collection of your systems and your servers. And then finally, you have the teams that take care of this infrastructure. So codes need to be updated whenever your infrastructure needs a new configuration or some sort of updation in the operating system or the software versions. Your code needs to be updated at first. And as the requirements of the company change, the infrastructure's configuration needs to change. And finally, of course, the people need coordination. So if you have a team of system administrators and say person A makes some change to the code, person B, C, D and so on need to be well aware when the change is made as to why it was made, what was the change made and where exactly this change was made. So there are two types of configuration management. On our left, we have the push configuration. Here the server that holds the files with instructions to configure your nodes pushes these files onto the node. So the complete control lies with the server. On your right side, we have the pull configuration. In case of pull configuration, the nodes poll against the server to first check if there's any change in the configurations required. If there is, the nodes themselves pull these configuration files. Chef follows pull configuration, and how it does this, we'll see further in our video. Another important term often used with Chef, infrastructure as code. So let's understand what this term infrastructure as code means through this small story. So here's Tim. Tim's a system administrator at a large company. Now he receives a task. He has to set up a server and he has to install 20 software applications over it. So he begins. He sets up the server, but then it hits him. It would take him the entire night to install 20 software applications. Wouldn't things have been much simpler if he just had a code to do so? Well, of course, codes do make things much simpler. Codes have a number of advantages. They're easily modifiable. So if today Tim is told we need MySQL installed on 20 systems, Tim simply writes a code to do so. And the very next day Tim is told, we changed our mind. We don't need MySQL. I think we'll just use Oracle. This does not bother Tim because now he just opens the file, he makes a few corrections in his code and that should work just fine. Code is also testable. So if Tim had to write 10 commands to do something and at his 10th command he realized the very first command he wrote, there was something not right there. Well, that would be quite tiresome, wouldn't it? With codes, however, you can test it even before running it and all the bugs can be caught and corrected. Codes are also deployable. So they're easily deployable and they're deployable multiple times. So now that we saw the various advantages of having codes, let's see what infrastructure as code exactly is. Here's the definition. Infrastructure as code is a type of IT infrastructure where the operation team manages the code rather than a manual procedure. So infrastructure as a code allows the operations team to take care of a code which automatically performs various procedures rather than having to manually do those procedures. So with this feature, all your policies and your configurations are written as code. Let's now look at the various components of Chef. So our first component is the workstation. The workstation is the system where the system administrator sits. He or she creates the codes for configuring your nodes. Now these codes, which in case of Chef are written in Ruby, are called the recipes. And you'll have multiple number of recipes. So a collection of recipes is called a cookbook. Now these cookbooks are only created at the workstation, but they need to be stored at the server. So the knife is a command line tool. So it's basically a command that you will see us executing in one of our demos that shifts these cookbooks from the workstation over to the server. Our second component is the server. So server is like the middleman. It lies between your workstation and your nodes. And this is where all your cookbooks are stored. Because as you saw previously, the knife sends these cookbooks over from the workstation to the server. The server can be hosted locally, that's on your workstation itself, or it can be remote. So you can have your server at a different location. You can even have it on the cloud platform. And our final component, the node. So nodes are the systems that require the configuration. In a Chef architecture, you can have a number of nodes. Ohai is a service which is installed on your node and it is responsible for collecting all the information regarding your current state of the node. This information is then sent over to the server to be compared against the configuration files and check if any new configuration is required. Chef Client is another such service on your node which is responsible for all the communications with the server. So whenever the node has a demand for a recipe, the Chef Client is responsible for communicating this demand to the server. Since you have a number of nodes in a Chef architecture, it's not necessary that each node is identical. So of course, every node can have a different configuration. Let's now have a look at the Chef architecture. So here we have a workstation, one server machine and two nodes. You can have any number of nodes. First things first, the system administrator must create a recipe. So the recipes that are mentioned in our Chef architecture are just dummy recipes. We'll look into actual functioning recipes later in our demo. So you have one recipe, two recipes, three recipes, and a collection of recipes forms a cookbook. So guys, if you look at the recipe, in source you have Simplilearn 3.erb. ERB is the extension for your Ruby files. So the cookbooks are only created at the workstation. They now need to be sent over to the server where they are stored. And this is the task of the knife. Knife is a command line tool which is responsible for transferring all your cookbooks onto the server from the workstation. Here's the command for running your knife. Knife upload simply-db, where simply-db is the name of the cookbook. We then move on to our node machines. At our nodes, we run the OHI service. The OHI service will collect all information regarding the current state of your nodes and send it over to the Chef client. When you run the Chef client, these informations are sent over to the server and they are tested against the cookbooks. So if there is any discrepancy between the current state of your nodes and the cookbook, that is, if one of the nodes does not match the configurations required, the cookbook is then fetched from the server and executed at the node. This sets the node to the right state. There are various flavors of Chef. We'll quickly go through these. First, we have Chef Solo. With Chef Solo, there's no separate server, so your cookbooks are located on the node itself. Now, this kind of configuration is used only when you have just a single node to take care of. The next flavor is a hosted Chef. With hosted Chef, you still have your workstation and your node, but your server is now used as a service on the cloud. This really makes things simple because you don't have to set up a server yourself and it still performs all the functioning of a typical Chef. This is the configuration you will notice that we'll be using in our demo. Chef Client Server. With Chef Client Server, you have a workstation, you have server, and you have n number of nodes. Now, this is the traditional Chef architecture. This is the one we have used for all the explanations previously. And finally, we have Private Chef. Private Chef is also known as Enterprise Chef. In this case, your workstation, server, and node all are located within the enterprise infrastructure. This is the main difference between Chef Client Server and Private Chef. In case of Chef Client Server, all these three machines could be dispersed. The enterprise version of Chef also provides the liberty to add extra layers of security and other features. And we reach the final part of our video where we'll have the hands-on. So before we dive into our demo, let me just quickly give you an introduction to it. We'll be using two virtual boxes, both CentOS 7. One will be used as a workstation while the other will be a node. So we are just using one node to make things simple. The server will be used as a service on the cloud. Now these are the steps we'll be performing during our demo. We'll first download and install the Chef DK on our workstation. We then make an empty cookbook file and we'll write a recipe into it. We need to then set up the server. So as I mentioned earlier, server will be a service on the cloud. So you'll have to create a profile, but this will be completely free. We then link the workstation to the server and will upload the recipe to the server. The nodes will now download the cookbooks from the server and configure themselves. So now that you have some idea about what we'll be doing, let's move on to the actual demo. We begin our demo. Here's my Oracle VM VirtualBox Manager. I have two machines here. I've already created my workstation and node. Both of these are CentOS 7 machines. Just for you to differentiate, this is my terminal. And for my workstation, it's a black background with white text. And as of my node, it's a black background with green text. The first thing you do is you go to your workstation box and open a web browser. Search for Chef DK installation. go to the first link, which is your Chef's official page, and under Red Hat Enterprise, because our system's a Red Hat system, select the link of the version that you're using. So I'm using CentOS 7. So my operating system version is 7. So I'll take this link. Now this is the link for downloading your Chef DK. You copy this link and go to your terminal. Guys, notice I'm in the home directory of my root user. So let's install our Chef DK. And it's getting installed. Now this will take some time because it's quite a large file. And Chef DK is downloaded. Next step, we need to install it. And this is the version of the Chef DK that we have downloaded. So type the same. Okay, so that's done. So now we need to make our recipes, and the recipes will exist within cookbooks. So first let's make a chef repository. So within that we'll have a folder for holding all our cookbooks, and within our cookbook we'll write our recipe. So we start with the directory for chef repository. Move into it. Create a folder called cookbooks, within which we'll store each of our cookbooks. Move into this folder. Okay, so we'll just check the contents here right now. So we have our Chef DK, we have a chef repo folder here, and let's check the contents of the chef repo. And this has cookbooks. Okay, so our first cookbook that we'll be making will be under this folder cookbooks. So let's move into cookbooks. We are in. Now we need to create our first cookbook. So the instruction for creating your first cookbook is chef generate cookbook and the name of your cookbook. So I'm just giving the name as sample. Yeah, so our cookbook sample is created. Now when you create your cookbook, you'll notice that a hierarchy is also automatically created. So let's just check the hierarchy of our cookbook. Let's move into sample, and tree is the command for checking the hierarchy. So here, as you can see, we have recipes, and under recipes we have default.rb. So we'll be editing this default.rb to create our recipe. Okay. So let's begin with that. Let's move into our recipes folder and open your default.rb. And here we are. So now we'll type in our code. So what's our recipe for? Our recipe is for installing the HTTPD package on our node, and then we'll also create a small index file where we'll just have a simple content such as welcome or something like that, just to check if our HTTPD is working fine. So let's begin typing the code here. Package HTTPD service HTTPD do. And what must be done with this package is that once it's installed, it needs to be enabled and it needs to be started. And so that's our first task. Our next task is creating our HTML file. So as you know, all your HTML files will follow this path name. And this is the content of your file. You have successfully configured your node. And that's it. That's our simple code. So our recipe is now ready. Save it and exit back to your terminal. Now what we need to do is that we need to configure our server. So go to your browser. On the search engine, type manage.chef.io. So as I mentioned earlier, we'll be using a server as a service on the cloud. So you'll enter your login page for the Chef server, Most of you may not have a profile already, so you go to click here to get started and fill in the details. It's just like creating an account on Facebook. So I already have my account. I've put in the credentials here. I'll just sign in. Now the first thing once you sign in is you'll get an option to create an organization. So all you have to do there is you gotta enter the name of your organization, and just below that there's another box for entering a short form of your organization. Now my organization name was Simplilearn and the short form was SLP123. So when you come to the administration tab under organization, you can see this organization name. Next step, click on this arrow and you got to download your starter kit. Okay, so once you click on starter kit, you'll come to this page where there's a button for download starter kit. So do download it. Save the file. So now come back to your terminal. So you come back to your terminal, and next what you need to do is you need to unzip your chef starter.zip. So for that, first we'll move our chef starter to the root. So it's currently present under the downloads folder. Let's move it. So we have moved our chef starter.zip. Now let's unzip it. First, let's just check the contents of our root directory right now. So we have our chef repository, chef repo folder that we created, the chef starter zip that we just moved, and of course the chef DK. So now we can unzip our chef starter kit. And that's done. So our next step, we got to move the chef starters.zip file into our cookbooks, which lies inside the chef repository. This is done because we'll be executing our further commands to connect our workstation with the server from the cookbooks, because that is where our sample cookbook is. And that's moved. So now we'll run a knife command. So what knife does is that it uploads your recipes or your cookbooks onto the server. So here's the command for running your knife. Samples the name of the cookbook that you're uploading, and uploading sample 0.1.0 and uploading sample. Yeah, so our cookbook is uploaded. Now let's just check this at our server. How we do that is go back to your browser where you have opened your server. So there's no node here yet because we have not configured our node with the server, but we have configured our workstation with the server. And you see here our cookbooks uploaded, sample. So our workstation and our server are connected. So now we need to connect our node with the server. So first we move on to our node machine. We need to take the IP address of our node machine. So for the IP address, we'll just type ifconfig. Right, so this is your IP address. 192.168.2.190. Note this down somewhere, guys. Now that's done. Go back to your workstation. I'll just keep it this way so I can see both. Okay. Go back to your workstation's terminal, but this time to connect our server with the node. So we have taken the IP of our node, and this is where we'll be using it. 192.168.2. The username, which is root in our case, and then enter the password, and then finally you enter your node name. So this is the name that will appear for this particular node on our server. I'm just giving it chef node. You can give it whatever you like. We'll just check the command knife, bootstrap, the IP address, SSH user, our user, which is root, SSH password, the password for the root, and finally the node name. And the node's getting created. So once the node is connected to your server, we'll go back to our browser, open our server service on the cloud, and we'll check the node tab. So ideally, your node name should appear there. Great. So our node is added. Also, if you notice here, our chef client service on the node has started running. So let's just check this with the server. Go to your nodes. And here we go. So chef node, a CentOS 7 platform. This is our IP. So it's all done. So now we need to add a cookbook to the run list of this node. So come here, click on this arrow, edit run list. Here's sample. This is the cookbook that we want to run on our node. Put on the current run list. And here we have the run button. Just click on that. So this should have transferred our cookbook onto the node. Let's check that. Go to your node machine. Clear this. We need to be the root. Let's run the chef client service. So we are running it once again because after it was started, we did add something to our run list. The changes in the run list is updated. So in 1 minute 56 seconds, our cookbook has run on our node. So the configuration changes should have been made. Let's check that. It's pretty simple. Just go to your browser. On the search engine, just type localhost. And here's our HTML page that we created on our workstation. Congrats, you configured your first node. And I really hope you did. So that is the end of our demo. We have successfully installed the HTTPD package on our node, and we have also executed a HTML file. So with that, we come to an end to our video. Now let's have a quick look at everything you learned today. First, you saw why you should probably use chef. Then what exactly is the chef? We looked into the two most important terms often used with chef, configuration management and infrastructure as code. We also saw the various components of chef and how these components work together to provide the capabilities that chef does. We looked into the 4 flavors of chef, and finally we wrapped it up with the demo on installing HTTPD package on our node and also writing a simple HTML file.
Hello, this is Matthew from Simplilearn. We're going to focus specifically on Puppet. So in this session, what we're going to do is we're going to cover what and why you would use Puppet. What are the different elements and components of Puppet and how does it actually work? And then we'll look into the companies that are adopting Puppet and what are the advantages that they have now received by having Puppet within their organization. And finally, we'll wrap things up by reviewing how you can actually write a manifest in Puppet. So let's get started. So why Puppet? So here is a scenario that as an administrator, you may already be familiar with. You as an administrator have multiple servers that you have to work with and manage. So what happens when a server goes down? It's not a problem. You can jump onto that server and you can fix it. But what if the scenario changes and you have multiple servers going down? So here is where Puppet shows its strength. With Puppet, all you have to do is write a simple script that can be written with Ruby and write out and deploy to the servers your settings for each of those servers. The code gets pushed out to the servers that are having problems, and then you can choose to either roll back to those servers to their previous working states or set them to a new state and do all of this in a matter of seconds. And it doesn't matter how large your server environment is, you can reach to all of these servers. Your environment is secure, you're able to deploy your software, and you're able to do this all through infrastructure as code, which is the advanced DevOps model for building out solutions. So let's dig deeper into what Puppet actually is. So Puppet is a configuration management tool. Maybe similar tools like Chef that you may already be familiar with. It ensures that all your systems are configured to a desired and predictable state. Puppet can also be used as a deployment tool for software. Automatically, you can deploy your software to all of your systems or to specific systems. And this is all done with code. This means you can test the environment and you can have a guarantee that the environment you want is written and deployed accurately. So let's go through those components of Puppet. So here we have a breakdown of the Puppet environment. And on the top, we have the main server environment. And then below that, we have the client environment that would be installed on each of the servers that would be running within your
network. So if we look at the top part of the screen, we have here our Puppet master store, which has and contains our main configuration files. And those are comprised of manifests that are actual codes for configuring the clients. We have templates that combine our codes together to render a final document. And you have files that will be deployed as content that could be potentially downloaded by the clients. Wrapping this all together is a module of manifests, templates, and files. You would apply a certificate of authority to sign the actual documents so that the clients actually know that they're receiving the appropriate and authorized modules. Outside of the master server where you'd create your manifests, templates, and files, you would have Puppet Client is a piece of software that is used to configure a specific machine. There are two parts to the client. One is the agent that constantly interacts with the master server to ensure that the certificates are being updated appropriately. And then you have the factor, the current state of the client that is used and communicated back to through the agent.
So now that we know what Puppet is, let's look into the Puppet architecture. So Puppet has a master-slave architecture. As you can see here, on the top we have the Puppet master and below we have the Puppet clients. So the Puppet master is the system where your system administrator sits. The clients are those systems which require configuration. You can have n number of clients connected to the Puppet master. So don't worry, we look into each of these components in detail. Firstly, we have the Puppet master. So the Puppet master is where the system administrator sits and he or she types in the codes here. So the codes are not only written in the system, but they are also stored here. And whenever the client requires these codes for their configuration, they simply request it. So manifest is the first subcomponent of the Puppet master. These are the actual files where the codes are written. So in case of Puppet, these are Ruby files. Modules tie manifests, templates, and files into a single unit. Now these codes dictate the instructions for performing various tasks on your client. The next component is templates. So if manifests are your code, templates are the data. So let me explain this to you with an example. Consider you want to create a file called index.html on one of your client machines. So what you do is, you write the code for creating this file in your manifest and the content of this file is written in your templates. Then you simply link them. But here's the thing, when you divide your code and data in this way, it's a very clean structure. So it's preferred to do it in this manner. Files are your static contents. So the files are basically sent to your client and they are simply downloaded at the client. There is no execution or compilation involved with your files. Now this is where files and templates are extremely different. Because with templates, they are never sent over to your client. The templates are simply read by the parser at the master itself. Modules ties the manifest, templates, and files into a single unit. So modules is not a separate component as such, it just provides a very clean hierarchy. This is the most important component of the Puppet master, CA, which stands for Certificate Authority. Now, as we will see later in this video, the Puppet master and the Puppet client communicate through an exchange of SSL certificates. So when the client sends over the certificate to the master, CA provides the master the authority to sign these certificates. The minute the master signs a certificate, the master is basically saying that yes, this client is registered with me and I agree to exchange data with this client. Our next component, Puppet client, of course these are the systems that require to be configured. Agent is a service installed on the client. The agent is solely responsible for all the communication between the master and the client. And finally, we have Factor. So Factor is responsible for collecting all the data about the present state of our client and sending this data over to the Puppet master. At the master, this data is compared against the manifests, which are your code files, and then these manifests are sent over to the client depending upon the results of this comparison. So now that we had a look at the various components of Puppet, let's see how these work together. So we have a master and we have 3 clients. Now before any information can be transferred between the master and the client, it's important that these components recognize each other. Also, there needs to be an encrypted channel of communication between each pair of master and client. Now all the data which is transferred between the master and the client, it flows through this channel. So let's see how this entire procedure of recognizing each other works. The core of this procedure are the SSL certificates. SSL stands for Secure Socket Layer. Secure socket layer is a security protocol and it forms an encrypted channel between two components. What this encrypted channel ensures is that all the data that is passed through this channel is not accessible by any other system outside. So it provides complete security. Okay, so we will consider a very general scenario. We have a master and a client here. This is not the Puppet master or the Puppet client. They are just two systems and we are just going forward with master-slave architecture. So the client so far is not a client. It is just a system and we will refer to the system as system A. So system A sends over a client certificate to the master. Associated with this client certificate is the host name of system A. Now master goes through this certificate, it sees the host name and then it decides whether it wants to form a communication link with the system A. If it does, it signs the certificate and this signed certificate is sent back to system A. Now the system A is officially a client. The minute the master signed the client certificate, it said that yes, I am willing to exchange information with this system and I do take the system as one of my clients. So now that the system is officially a client, it can request for data from the master and the master will simply send over the data. Now we are here to talk about Puppet. So if this was a Puppet master and this was a Puppet client, then the first three stages will be the same. So the Puppet client sends over the certificate to the master signs the certificate, sends it back, and the client requests for data. Now by data here, of course, we mean the configuration data. Those are the manifest or even could be your files. So what happens after this request? After this request, the factor service which is present on your clients collects all the information regarding the present state of your client. So this information could include the operating system that's installed on them, the various number of software present on them, the versions of these software. Now all this information is collected, it's called the fact and it's sent over to the master. At the master, this information, that is the facts, is compared against the manifest. So why does the master do this? The master basically compares the facts against the manifest to know if what the manifest is about to perform is already performed on these systems. So if the manifest has some additional functionality, they are compiled into catalogs and then these catalogs are sent over to the client. Now remember those agent services which existed in your clients? Here's where they come in. The agents take the catalog and execute them on the client. Once executed, these catalogs make the required changes on the client and a report is generated. This report is then sent back to the master. So the master keeps record of all the changes that's made in the system, and this comes very handy when one of the systems fail and it's required to be rolled back to its previous working state. So this entire procedure can be repeated n number of times and it can be repeated at regular intervals. So if you have a scenario where a system needs to be configured every 30 minutes, what you can do is you can set your interval and automatically every 30 minutes your systems will be configured. So today I'll be showing you how you can use Puppet to install Apache on one of your client machines. So we'll be using two machines here. We'll have a server and we'll have a node machine. The server is essentially your master. The node is your client. I'm just using the term server and node instead because I want to keep it very close to as they are used in the commands. Now both these machines are going to be CentOS 7 machines. And I have Oracle VM VirtualBox installed on my machine. So on that, I've simply created two virtual boxes, both CentOS 7 of course. So before we move on to the actual demo, I'll just take you through the various steps. So first we'll install the Puppet server on our server or master machine. We'll then start this server service. We then shift over to our node or the client machine and we'll install the Puppet agent service. We will then start this service too. And the minute you start the Puppet agent service, an SSL certificate is created. So this certificate will have the host name of your node attached to it. And this is how the master or the server will recognize this certificate and then it will sign this certificate. So once your master or the server signs the certificate, you can write your manifests. So the manifests are just the code for configuration. And once that too is done, you shift back to your client or the node system and you run the agent service. So once you run the agent service, your manifest or your catalogs, because as you know, the manifests are compiled into catalogs, these are executed on your node and this will make the required changes. So that's how this entire process is going to work. Now let's move on to the actual demo. This is my Oracle VM VirtualBox Manager. The last two machines you see here are the ones we'll be using for this demo. The Puppet server is your Puppet master, Puppet client, of course, is the client. So let's just have a look at these two machines. This is my Puppet server. So just so you can differentiate, guys, the terminals have been set accordingly. Puppet server has a black background with white text, and Puppet client here has a black background with green text. So we'll move on to server machine or the master machine because that's the one we'll be working on first. So before we begin, we need to set the host name of our master to Puppet. So this is a very essential step in the configuration of Puppet. If you miss this out, there are quite a lot of other changes you'll have to make in certain files. So let's do this first. So that's the command to set the host name. The last word you see there, that's the new host name you want. Okay, so now we'll just check if our host name is set. So just type host name. And yeah, it's Puppet. So next, we will check the IP of this machine. So for that, you just type ifconfig. Enter. So this is your IP, guys, under ENP0S3, init's value, that is 192.168.2.183. Of course, the IP will differ for you guys, needless to say. So note that down somewhere because we'll require it when we are configuring our client. Okay, so now you want your Puppet server and your client to communicate. So for this, we need to remove certain firewalls. So the command for this is sudo, because we want the root permission, systemctl stop firewall D and put in the password. Okay, so all your firewalls are removed. So the next step, now we start on with our Puppet process. So we download the Puppet labs at first. Now guys, ensure that your systems, your virtual boxes in this case, are connected to the net. Also, you won't be getting an IP if it's not for the first time. So here's the command to download the Puppet lab. Enter the password again. Okay, so the Puppet Labs is downloaded. Now you need to install this. So installation, guys, we will be installing the Puppet server on the master machine or the Puppet server machine. So this may take a while. So that took a while, so I just skipped to the last part where it's completed. The installation process is over. Now we need to make a small change in our system config Puppet server file. So let's just move to the file first. This file will open in VI editor. So this line here, it basically allocates memory for your Puppet server. Now you do not need 2 GB. So we are going to reduce the size. "512 MB should be enough. So guys, notice here I did not type the B, okay? So I just changed this to XMS 512M. Let's save that. Always remember to open this file using sudo. Otherwise, saving the changes you made could be quite troublesome. Okay, so now we can start our Puppet server service. We enable the service. Okay, so that's done. So basically our Puppet server service has started. It's running presently. So for a while we are done with the server machine. Let's move on to our client machine. Okay, first things first, we open our etc host file with sudo because you need to make a few changes and save it. Open this in the VI terminal. Okay guys, so here you have to add this one line at the end. Type in the IP for your Puppet server machine. Puppet dash master. So let's save this file. Now we'll move on to downloading Puppet Labs on our Puppet client. So the command is the same that we use for Puppet server. So Puppet Labs is downloaded. Now we need to install the Puppet agent service here. Again, this will also take some time. Puppet server is installed. Let me just clear this window. Now that our Puppet agent service is installed, we'll start this service. So I'll just type in the command for starting the Puppet agent service. As you can see here, ensure changed stop to running. So basically the service was not running before and now it's changed to the running state. And while we executed this command, not only did the service start running, but an SSL certificate was also created. So this certificate should have the host name of this machine, that's a Puppet client machine, attached to it. So let's just check what the host name of our machine is. That's localhost.localdomain. So our certificate should have this attached to it. So guys, the first time your client sends a certificate, the name of the certificate itself is usually the host name of the machine. So our certificate's name should be localhost.localdomain. We'll check this on our master system, and that's where we'll sign the certificate to. So first we list out all the certificates. In our case, since we have just one client and we just started the client, we should have technically just one certificate, and it will be so. Yeah, so this is our certificate, localhost.localdomain. We'll now sign the certificate. Okay, sorry about that. Just need to remove these brackets. Yeah, as you can see here, the certificate is signed. Sign certificate request here. So once the certificate is signed, the request for signing the certificate is removed. That's this line. Now that a certificate is signed, we can begin to write our manifest. So let's move into a manifest folder and we'll create a placeholder file. So we'll create a file called sample.pp. This is just a sample file. We won't be writing anything in this file as of now. So we are just checking here. We are just creating this file and then we'll go to our client machine and just check there if we can access this file from there. So now we'll move to our client machine. So let's test the connection. So as you can see here, it says applied catalog in 0.03 seconds. So our catalog is executed on our client machine. Now our catalog was just a placeholder basically. So the file that we created, which is sample.pp, had no content and we were just testing our client. Now let's go back to our master server, put some content into this file and see how the execution takes place. So we'll open our file sample.pp, which we created earlier in the VI editor. Let's type our code here. So node, and then within the brackets we enter the host name of our client machine. So this ensures that our manifest is executed on this particular machine. Now the Apache service package on CentOS is called the HTTPD. So this line that I just typed in is the action. It will ensure that the HTTPD package is installed on your client. And that's it. So this is our code. We'll save it. Now let's go back to our client machine and test it. So this is our client machine. And our catalog's applied on the client. So I just cleared the screen. Now we'll start the Apache service. Okay, so how do we see if it's running? We just need to go to our browser and at localhost, you must have the testing page for your Apache. So we type localhost, enter. And yeah, this is the testing page for Apache. So as you can see, we have successfully used Puppet to install the Apache service on our Puppet client. And this is the end of the demo.
So let's have a look at companies that are using Puppet today. There are a number of companies that have adopted Puppet as a way to manage their infrastructure. So companies that are using Puppet today include Spotify, Google, AT&T. So why are these companies choosing to use Puppet as their main configuration management tool? And the answer can be seen if we look at a specific company. Staples. So Staples chose to take and use Puppet for their configuration management tool and use it within their own private cloud. The results were dramatic. The amount of time that the IT organization was able to save in deploying and managing their infrastructure through using Puppet enabled them to open up time to allow them to experiment with other and new projects and assignments, a real tangible benefit to a company. So let's look at how you write a manifest in Puppet. So manifests are designed for writing out in code how you would configure a specific node in your server environment. The manifests are compiled into catalogs, which are then executed on the client. Each of the manifests are written in the language of Ruby with a .pp extension. And if we step through the 5 key steps for writing a manifest, they are 1. Create your manifest, and that is written by the system administrator. 2. Compile your manifest, and it's compiled into a catalog. 3. Deploy. The catalog is then deployed onto the clients. 4. Execute. The catalogs are run on the client by the agent. And then 5. End. Clients are configured to a specific and desired state. If we actually look into how a manifest is written, it's written with a very common syntax. If you've done any work with Ruby or really configuration of systems in the past, this may look very familiar to you. So we break out the work that we have here. You start off with a package, file, or service as your resource type, and then you give it a name, and then you look at the features that need to be set, such as IP address. Then you're actually looking to have a command written, such as present or start. The manifest can contain multiple resource types. If we continue to write our manifest in Puppet, the default keyword applies a manifest to all clients. So an example would be to create a file path that creates a folder called sample in a main folder called etc. The specified content is written into a file that is then posted into that folder. And then we're going to say we want to be able to trigger an Apache service, and then ensure that that Apache service is installed on a node. So we write the manifest and we deploy it to a client machine. On that client machine, a new folder will be created with a file in that folder, and an Apache server will be installed. You can do this to any machine and you'll have exactly the same results on those machines.
Now let's have a look at the Puppet community. The Puppet community is a rich community of a lot of people. Officially, there is no count. But counting the various channels where people collaborate, there are a little over 2,900 committers to GitHub projects who are directly or indirectly associated with Puppet Labs. There are 4,893 modules on the official Puppet Forge. These include modules from the Puppet Labs and also from open source contributors to GitHub. So that's nearly 5,000 modules of ready-made code available on the Puppet Forge. So before you write any code for Puppet, you can check to see if it's already been written by someone. Now there's a mailing list which has 6,588 participants. Apart from this, on Slack Overflow you have a big tag of Puppet Labs and Puppet, which gives you a list of only Puppet questions. That's a good playground for you to interact with people who are already using Puppet and who are contributing and helping others. Now let's have a look at Puppet Forge. So Puppet Forge is a GitHub client for a repository which is hosted by Puppet Labs. It has almost 5,000 modules of Puppet code. So these are both Puppet Labs and community contributed. The best thing about this is that they're easy to customize. So when you have a requirement for anything you're doing with your infrastructure, you can just grab one of those 5,000 modules, and then you can customize it according to your needs. One of the other benefits is they have built-in tests, so they follow all of the best practices. Now, if you write your own module, you also have to write your own tests, and you have to spend extra time writing best practice code. All of that has been taken care of, and you can just download any one of those and customize it according to your needs, and you're good to go. So that's the benefit you get from such a large community, where people contribute to the modules and the code and share with the community. The Puppet DSL. Puppet DSL is a Puppet domain-specific language. It's the Puppet's primary programming language. It's just like plain English, and you don't really need to be a programmer to write code in it. It's kind of a subchild of Ruby because it approaches and uses is equal to and greater than marks to define things, so it's very easy to learn. You can specify packages that you want to install. You can specify services to be managed. You can do things based on the operating system that you have. So we'll be writing a small Puppet module which will be using this Puppet DSL. We will do that after we install the Puppet server and the client. And then we will write a simple Puppet module to show how to use the Puppet DSL. Let's have a look at the demo we are going to do. So you will be setting up the machines using sudo DNS because we want to have a resolvable DNS. Because only by having a resolvable DNS can we use Puppet, because Puppet uses the SSL certificates. Now we'll be installing the Puppet server and the client. We'll be signing the certificates of the client on the server side. And then we'll proceed with writing an NTP module, which we'll be using for installation of NTP on the client. And then we'll look at the Puppet programming language, or DSL. Now, we are going to look at a demo here. So we will be setting up the machines. We'll set up a sudo DNS locally because Puppet requires a fully qualified domain name in order to run, since there is a certificate communication taking place here. We will be installing the Puppet server, the Puppet client. We'll be signing the certificate, and finally we will write an NTP module and make it run. So now we will be starting a Puppet master and a client. I have two machines here. One is the Puppet Master and the second is the Puppet Client. The Puppet Master has got almost 4 GB of RAM and 4 vCPUs, which I can show you here. Because it's a Ruby on Rails application, it requires a lot of CPU and RAM. For the client, I don't need that much RAM and CPU, so I've allotted 1 gigabyte of RAM and 1 vCPU. I will start both of these machines and find out the IP addresses. Right-click, normal start. Both of these machines are starting up. The Puppet client has started up, and the first thing I'll do is log in using root and Red Hat password, and then I will change the host name. So I'll say vim etc host name. This will open a hostname file in a text editor, which is vim. Then we'll do a dd, which will delete that existing host name. And then I press the I for insert mode, and finally I'll type the Puppet-client, which will be the host name of this machine. I'll save this file by doing escape semicolon WQ exclamation mark. And I'll reboot the machine. Similarly, going to the Puppet master, I'll say root Red Hat. I'll open the hostname file. Say dd, then I'll say Puppet-master. I'll save this file and reboot the machine for the hostname change to take effect. The hostname change does not take effect unless you reboot the machine. Now both of these machines are ready. I'm going to find out the IPs and use the Mac terminal to log into these. So this is 23 and 21. So 23 is my server and 21 is my client. I'll SSH to 23 first. Now, in order for the Puppet Master to be installed, I need a fully qualified domain name here and a fake DNS, which means a fully resolvable DNS name. So if I do host name here, you see my host name is Puppet Master. In order to set up a fake DNS, I need to go to the etc host file, go to the end, then I say IP address, host name local, then space host name. Now, this is one of the techniques which makes the Linux server believe that there's a fully qualified domain name on this machine. I'll save this. Then I do a host name -f. You see it has a fully qualified domain name now. So now we will be downloading the Puppet Labs repository for Ubuntu 16.04, which is Xennial. So I'll say curl -0 https apt.puppetlabs.com /puppetlabs-release -pc1 -xennial.deb. You can see there's a Debian file which has been downloaded here. I will import this using the dpkg command. So I'll say dpkg-i puppetlabs-release -pc1 -xennial.deb. And then I'll say apt-get update, which will update my apt package indexes on this machine. And now I'll install the Puppet server. So I'll say apt-get install puppet server -y. So the Puppet server is now installed, and we will be configuring the memory allocation for the Puppet server. So I'll say etc default Puppet server. So by default, it has only got 2 GB allocated. We'll give it 3 GB because it's JVM. I'll make this 3, and I'll change this to 3 as well. And I'll save this file. I'll make sure the unconfigured firewall allows port 8140, which is the Puppet Lab Puppet server port. The rules have been updated to allow that. I'll now start the Puppet server. So I'll say systemctl start Puppet server. It takes some time because it's a JVM, so it takes a couple of minutes to start the Puppet server. So the Puppet server is now running. I'll also enable it at boot time, so I'll say systemctl enable Puppet server. It will enable at boot time. Now I also need to configure a fully qualified domain name here. So I'll do that by going into the hosts file. I'll go to the end and I'll say 192.168.1.23 and then puppet-server.local and then puppet-server. If I do a hostname -f, put -master.local because the current hostname is puppet-master. So the trick is to have the hostname.local in front of the IP address in the host file. Having a fully qualified domain name now we will go to the client setup. The client setup is almost the same with just a small difference. The package which we need to install on the client is Puppet Agent. So we will go to the client. So you see this has got a host name. Now we also need to set up the fake DNS here. So I'll copy this host name, open the host line, go to the end, write the IP address, and then .local, and then host name again. So this will give me a fully qualified domain name. So when I do a host name, it says puppet-client. When I do a host name -f, it says puppet client local. To install the Puppet agent on this machine, I will need to download the Xenio packages. So I'll say wget https apt.puppetlabs.com/puppetlabs -release -pc1 -xenio.deb. I'll download this, and then I'll say dpkg-i puppetlabs-release -pc1 -xenio.deb. So this is the repository package which I'll be downloading here. And then I'll say apt-get update-y. This will update my apt caches on this machine. And now I'll finally install the Puppet agent. So I'll say apt-get install Puppet agent -y. Now the Puppet agent is here. I'll start the Puppet agent and I'll enable it at boot time. So I'll say system control, start Puppet, then system control, enable Puppet. Now Puppet is enabled. Now we have set up the fully qualified domain name on the client and the server, but each of them should know each other. So we'll have to do a cross-certificate host mapping. So we will be copying the host file entry of the client and adding it to the server. So I'll go to the etc hosts on the server side. Go to the end, paste it there. Okay, and I'll be adding the entry of the master on the client side. Okay, now both of the servers will recognize each other now, because one of them has the host entry of the other. So if I do from the master ping puppet-agent.local, if I ping the agent from the server, -client.local, it is able to ping it. And if I ping the master from the client, if I say ping puppet-master.local, both of them will be able to ping each other. Now the next step would be to create a certificate signing request. So I'll go to my to this directory, which is opt puppet labs puppet bin, and I'll say puppet agent -t -server is equal to, and I'll give the fully qualified domain name of the puppet master. Then I'll say -f. When I do this, it will create a certificate signing request, you see. Now, if I go to the server and I do an opt, I'll check and see how many certificates are pending to be signed. You'll see there is a Puppet client certificate which is pending to be signed, which is denoted by the absence of a plus sign here. I'll be signing the certificate, so I'll say Puppet cert sign and then the name. So puppet-client.local. This will sign the certificates. And when I go to the server on the client side, if I run the Puppet agent again, you see it's actually pulling down the catalog. As of now, it has an empty catalog. That says there is nothing. Now we have configured the Puppet agent and the master. Now we will be taking a module from Puppet Forge. Puppet Forge is a big collection of open source modules which are free to use. As a first step, we will be using a ready-made module, and that would be a demonstration for how to actually get up and running with a module. So search for Apache module here. This is the Puppet Labs Apache module. I'll be using the Puppet command line, Puppet module install. This is the command for that. But I will make sure I run this command from the Puppet home. So I'll go to the master, I'll go to etc Puppet Labs, code, environments, production. In this, I'll do modules. Now I will run it from the binary which is present at the opt Puppet Labs bin Puppet. And then module install. Puppet Labs-Apache, and then this version. So we are specifying the latest version, and I'll hit enter. When I press enter, it starts downloading from the Forge API. So you see the module is downloaded in addition to the dependencies. So there is concat, stdlib, and Apache. So now I'll go to a folder here which is one level up called manifests. So this is the file here, etc Puppet Labs code environments production manifests. So in this there's a file which I'll be creating called site.pp. The site.pp will specify, and this is the main controller of how the infrastructure looks. In the site.pp, I specify that I want puppet-client.local node to have the Apache module included. I'll save this file, and the only thing I need to do now is, since all is set on the server side, I need to go to the client side and run Puppet agent. It will automatically download the Apache module and compile it, and then make sure the server is in a state. So when I press enter, we see a lot of output. It tries to configure Apache on this machine, and done. Now when I go to the front end of this machine, on this port, I should be able to see Apache's default page. So this is Apache's default page. So the module which we downloaded from the Forge was actually written in a way that Apache would be installed and run at boot time. So that is why it is running here. And that is all we have from the Puppet module. And this concludes the demo.
Today I'll be showing you how you can install the configuration management tool, Ansible. So let's have a brief about why one would use Ansible and what exactly is Ansible. So if you consider the case of an organization, it has a very large infrastructure, which means it has more than probably hundreds of systems. And giving one or even a small team of people the responsibility to configure all these systems makes their work really tough, repetitive, and as you know, manual work is always prone to errors. So Ansible is a tool which can automate the configuration of all these systems. With Ansible, A small team of system administrators can write simple codes in YAML, and these codes are deployed onto the hundreds and thousands of servers, which configures them to the desired states. So Ansible automates configuration management, that is configuring your systems. It automates orchestration, which means it brings together a number of applications and decides an order in which these are executed, and it also automates deployment of the applications. Now that we know what Ansible does, let's move on to the installation of Ansible. So here is my Oracle VM VirtualBox Manager. I'll be using two systems. There's the node system, which is basically my client system, and there's the server system or the master system. So let's begin at our server system. So this is my master system, guys. So the first thing we do is we download our Ansible tool. So one thing we must remember with Ansible is that unlike Chef or Puppet, Ansible is a push type of configuration management tool. So what this means is that the entire control here lies with your master or your server system. This is where you write your configuration files, and these are also responsible for pushing these configuration files onto your node or client system as and when required. Great, so our Ansible tool is installed. Now we need to open an Ansible host file, and there we'll specify the details of our node or client machine. So this is our Ansible host file. As you can see here, the entire file is commented, but there's a certain syntax that you'd observe. For example, here we have a group name, web servers, under which we have the IP addresses or certain host name. So this is about how we'll be adding the details for our client system. First, we need to give a group name. Under this group, basically, we add all the clients which require a certain type of configuration. Since we are using just one node, we'll give only the details for that particular node. First, we need to add the IP address of our client machine. So let's just go back to our client machine. And this here is the IP address, 192.168.2.11. Once you have typed in your IP address, give a space, and then we'll specify the user for our client machine. So all communications between the server or the master system and the client or the node system takes place through SSH. SSH basically provides a secure channel for the transfer of information. Follow this up with your password. In my case, it's the root's password. And that's it, we are done. So now we save this file and go back to our terminal. So now that our host file is written, the next thing we do is we write our playbook. So playbook is the technical term used for all the configuration files that we write in Ansible. Now playbooks are written in YAML. YAML's extremely simple to both write and understand. It's in fact very close to English. So now we'll write our playbook. The playbook or any code in YAML first starts with 3 dashes. This indicates the beginning of your file. Next thing, we need to give a name to our playbook. So name, and I'm going to name my playbook sample book. We next need to specify our host systems, which is basically the systems at which the configuration file or the playbook in our case will be executed. So we'll be executing this at the client machines mentioned under the group Ansible servers. So we had just one client machine under it. We'll still mention the group name. We next need to specify the username with which we'll be logging into our client machine, which is root in my case. And become true specifies that you need to become the root to execute this playbook. So becoming the root's called a privilege escalation. Next, we need to specify our tasks. So these are basically the actions that the playbook will be performing. So you would have noticed everything so far is aligned, that is name, host, remote user, become and task, because these are at one level. Now whatever comes under task will be shifted slightly towards the right. Although YAML is extremely simple to understand and read both, it's a little tricky while writing because you need to be very careful about the indentations and the spacing. So my first task is install HTTPD, which is basically an Apache server. So now my command's yum, and this will be installing the HTTPD package. And the latest state of it will be installed. So that's our first task. Now our second task would be running our Apache service. So name run HTTPD, and the action, which is service, will be performed on HTTPD, hence the name HTTPD, and state must be started. Now we come to our third task. So here we'll create a very simple web page that will be hosted. So create content is the name of our task. And the content that we are creating here will basically be copied to our node system at a particular file location that we'll provide. Our content will be congrats. And then we'll provide the destination at which this file will be copied. So this is the default location for all our HTML files. And that's it. We are done writing our playbook. Just save this and go back to your terminal. Before we execute the playbook or push the playbook onto our node system, let's check the syntax of our playbook. So the command for doing so is, and if everything's fine with your playbook, the output would be just your playbook name. So our syntax is perfectly fine. Now we can push on the playbook to our node or the client machine. And that's the syntax for doing so. Now, as your playbook is being sent over to the client machine, you can see that first the facts are gathered. That is, the current state of your client machine is first fetched to check what all is to be changed and what is already present. So the first thing is installing HTTPD. So our system already had HTTPD. So it says OK, because this does not need to be changed. Our next task was running HTTPD. Now, although our system had the Apache service, it was not running. So that is one thing that was changed. The next was there was no content available. So the content was also added. So 2 tasks were changed and 4 things were okay. Now everything seems fine. And before you move any forward, it is very important that you check this one line of documentation provided by Ansible. You have all kind of information available here regarding which all tasks were executed, if your client machine was reachable or unreachable, and so on. So now that everything's fine here, we can move on to our node system and we'll just go to our browser. So if our playbook has been executed here, what should happen is that the HTTPD service must be in the running state and the web page that we created should be hosted. So let's just type localhost. And great, everything's working fine. So our web page is displayed here. So we come to an end for our installation and configuration video for the configuration management tool Ansible. If you have any doubts, please post them in the comment section below and we'll definitely get back to you as soon as possible.
Ansible today as one of the key tools that you would have within your DevOps environment. So the things that we're going to go through today is we're going to cover why you would want to use a product like Ansible, what Ansible really is and how it's of value to you in your organization, the differences between Ansible and other products that are similar to it on the market and what makes Ansible a compelling product. And then we're going to dig into the architecture for Ansible. We're going to look at how you would create a playbook, how you'd manage your inventory of your server environments, and then what is the actual workings of Ansible. As a little extra, we're going to also throw in Ansible Tower, one of the secret source solutions that you can use for improving the speed and performance of how you create your Ansible environments. And finally, we're going to go through a use case by looking at Hootsuite, a social media management company, and how they use Ansible to really improve the efficiency within their organizations. So let's jump into this. So the big question is, why Ansible? So you have to think of Ansible as another tool that you have within your DevOps environment for helping manage the servers. And this definitely falls on the operations side of the DevOps equation. So if we look here, we have a picture of Sam. And like yourselves, Sam is a system administrator. And he is responsible for maintaining the infrastructure for all the different servers within his company. So some of the servers that he may have that he has to maintain could be web servers running Apache. They could be database servers running MySQL. And if you only have a few servers, then that's fairly easy to maintain. I mean, if you have 3 web servers and 2 database servers, and let's face it, wouldn't we all love just to have 1 or 2 servers to manage? It would be really easy to maintain. The trick, however, is as we start increasing the number of servers, and this is a reality of the environments that we live and operate in, it becomes increasingly difficult to create consistent setup of different infrastructures such as web servers and databases, for the simple reason that we're all human. As if we had to update and maintain all of those servers by hand, there's a good chance that we would not set up each server identically. Now, this is where Ansible really comes to the rescue and helps you become an efficient operations team. Ansible, like other system solutions such as Chef and Puppet, uses code that you can write and describe the installation and setup of your servers. So you can actually repeat it and deploy those servers consistently into multiple areas. So now you don't have to have one person redoing and refollowing setup procedures. You just write one script and then each script can be executed and have a consistent environment. So we've gone through why you'd want to use Ansible. Let's step through what Ansible really is. So, this is all great, but, how do we actually use these tools in our environment? So Ansible is a tool that really allows you to create and control 3 key areas that you would have within your operations environment. First of all, there's IT automation. So you can actually write instructions that automate the IT setup that you would typically do manually in the past. The second is the configuration and having consistent configuration. Imagine setting up hundreds of Apache servers and being able to guarantee with precision that each of those Apache servers is set up identically. And then finally, you want to be able to automate the deployment so that as you scale up your server environment, you can just push out instructions that can deploy automatically different servers. The bottom line is you want to be able to speed up and make your operations team more efficient. So let's talk a little bit about pull configuration and how it works with Ansible. So there are 2 different ways of being able to set up different environments for server farms. One is to have a key server that has all the instructions on, and then on each of the servers that connect to that main master server, you would have a piece of software known as a client installed on each of those servers that would communicate to the main master server and then would periodically either update or change the configuration of the slave server. This is known as a pull configuration. An alternative is a push configuration, and the push configuration is slightly different. The main difference is, as with a pull configuration, you have a master server where you actually put up the instructions. But unlike the pull configuration where you have a client installed on each of the services, with a push configuration, you actually have no client installed on the remote servers. You simply are pushing out the configuration to those servers and forcing a restructure or a fresh clean installation in that environment. So Ansible is one of those second environments where it's a push configuration server, and this contrasts with other popular products like Chef and Puppet, which have a master-slave architecture with a master server connecting with a client on a remote slave environment where you would then be pushing out the updates. With Ansible, you're pushing out the service and the structure of the server to remote hardware, and you are just putting it onto the hardware irrelevant of the structure that's out there. And there are some significant advantages that you have in that you're not having to have the extra overhead weight of a client installed on those remote servers having to constantly communicate back to the master environment. So let's step through the architecture that you would have for an Ansible environment. So when you're setting up an Ansible environment, the first thing you want to do is have a local machine. And the local machine is where you're going to have all of your instruction and really the power of the control that you'd be pushing out to the remote server. So the local machine is where you're going to be starting and doing all of your work. Connected from the local machine are all the different nodes pushing out the different configurations that you would set up on the local machine. The configurations that you would write, and you would write those in code, are within a module. So you do this on your local machine for creating these modules, and each of these modules is actually consistent playbooks. The local machine also has a second job, and that job is to manage the inventory of the nodes that you have in your environment. The local machine is able to connect to each of the different nodes that you would have in your hardware network through SSH clients, so a secure client. Let's dig into some of the different elements within that architecture. And we're going to take a first look at playbooks that you would write and create for the Ansible environments. So the core of Ansible is the playbook. This is where you create the instructions that you write to define the architecture of your hardware. So the playbook is really just a set of instructions that configure the different nodes that you have, and each of those set of instructions is written in a language called YAML. And this is a standard language used for configuration server environments. Did you know that YAML actually stands for YAML Ain't Markup Language? That's just a little tidbit to hide behind your ear. So let's have a look at one of these playbooks it looks like. And here we have a sample YAML script that we've written. So you start off your YAML script with 3 dashes, and that indicates the start of a script. And then the script itself is actually consistent of 2 distinct plays. At the top we have play 1, and below that we have play 2. Within each of those plays we define which nodes are we targeting. So here we have a web server in the top play, and in the second play we have a database server that we're targeting. And then within each of those server environments we have the specific tasks that we're looking to execute. So let's step through some of these tasks. We have an install Apache task, we have a start Apache task, and we have an install MySQL task. And when we do that, we're going to actually execute a specific set of instructions. And those instructions can include installing Apache and then setting the state of the Apache environment, or starting the Apache environment and setting up and running the MySQL environment. So this really isn't too complicated, and that's the really good thing about working with YAML, is it's really designed to make it easy for you as an operations lead to be able to configure the environments that you want to consistently create. So let's take a step back though. We have 2 hosts. We have web server and database server. Where do these names come from? Well, this takes us into our next stage and the second part of working with Ansible, which is the inventory management part of Ansible. So the inventory part of Ansible is where we maintain the structure of our network environment. So what we do here is part of the structure in creating different nodes is we've had to create 2 different nodes here. We have a web server node and a database server node. And under web server node, we actually have the names that we're actually pointing to specific machines within that environment. So now when we actually write our scripts, all we have to do is refer to either web server or database server, and the different servers will have the instructions from the YAML script executed on them. This makes it really easy for you to be able to just point to new services without having to write out complex instructions. So let's have a look at how Ansible actually works in real world. So the real world environment is that you would have the Ansible software installed on a local machine, and then it connects to different nodes within your network. On the local machine, you'll have your playbook, which is the set of instructions for how to set up the remote nodes. And then to identify how you're going to connect to those nodes, you'll have an inventory. We use secure SSH connections to each of the servers, so we are encrypting the communication to those servers. We're able to grab some basic facts on each server, so we understand how we can then push out the playbook to each server and configure that server remotely. The end goal is to have an environment that is consistent. So let's ask you a simple question. What are the major opportunities that Ansible has over Chef and Puppet? Really like to hear your answers in the comments below. Pop them in there and we'll get back to you, and really want to hear how you feel that Ansible is a stronger product, or maybe you think it's a weaker product as it compares to other similar products in the market. Here's the bonus. We're going to talk a little bit about Ansible Tower. So Ansible Tower is an extra product that Red Hat created that really kind of puts the cherry on the top of the ice cream, or is the icing on your cake. Ansible by itself is a command line tool. However, Ansible Tower is a framework that was designed to access Ansible. And through the Ansible Tower framework, we now have an easy to use GUI. This really makes it easy for non-developers to be able to create the environment that they want to be able to manage in their DevOps plan without having to constantly work with the command prompt window. So instead of opening up terminal window or a command window and writing out complex instructions only in text, you can now use drag and drop and mouse click actions to be able to create your appropriate playbooks, inventories, and pushes for your nodes. All right, so we talked a lot about Ansible. Let's take a look at a specific company that's using Ansible today. And in this example, we're going to look at Hootsuite. Now, Hootsuite, if you've not already used their products, and they have a great product, Hootsuite is a social media management system. They are able to help with you managing your pushes of social media content across all of the popular social media platforms. They're able to provide the analytics, they're able to provide the tools that marketing and sales teams can use to be able to assess a sentiment analysis of the messages that are being pushed out. Really great tool and very popular. But part of their popularity drove a specific problem straight to Hootsuite. The challenge they had at Hootsuite is that they had to constantly go back and rebuild their server environment, and they couldn't do this continuously and be consistent. There was no standard documentation, and they had to rely on your memory to be able to do this consistently. Imagine how complex this could get as you're scaling up with a popular product that now has tens of thousands to hundreds of thousands of users. This is where Ansible came in and really helped the folks over at Hootsuite. Today, the DevOps team at Hootsuite write out playbooks that have specific instructions that define the architecture and structure of their hardware nodes and environments, and are able to do that as a standard product. Instead of it being a problem in scaling up their environment, they now are able to rebuild and create new servers in a matter of seconds. The bottom line is Ansible has been able to provide Hootsuite with IT automation, consistent configuration, and free up time from the operations team so that instead of managing servers, they're able to provide additional new value to the company.
Ansible is currently the most trending and popular configuration management tool, and it's used mostly under the DevOps approach. So what will you be learning today? You'll learn why you should use Ansible, what exactly is Ansible, the Ansible architecture, how Ansible works, the various benefits of Ansible, and finally we'll have a demo on the installation of Apache or the HTTPD package on our client systems. We'll also be hosting a very simple web page, and during this demo I'll also show you how you can write a very simple playbook in YAML and your inventory file. So let's begin. Why should you use Ansible? Let's consider a scenario of an organization where Sam is a system administrator. Sam is responsible for the company's infrastructure. A company's infrastructure basically consists of all its systems. This could include your web servers, your database servers, the various repositories, and so on. So as a system administrator, Sam needs to ensure that all the systems are running the updated versions of the software. Now, when you consider a handful of systems, this seems like a pretty simple task. Sam can simply go from system to system and perform the configurations required. But that is not the case with an organization, is it? An organization has a very large infrastructure. It could have hundreds and thousands of systems. So here is where Sam's work gets really difficult. Not only does it get tougher, Sam has to move from system to system, performing the same task over and over again. This makes Sam bored. Not just that, repeating the same task leaves no space for innovation. And without any ideas or innovation, how does the system grow? And the worst of it all is manual labor is prone to errors. So what does Sam do? Well, here is where Ansible comes in use. With Ansible, Sam can write simple codes that are deployed onto all the systems and configure them to the correct states. So now that we know why we should use Ansible, let's look at what exactly is Ansible. Ansible is an IT engine that automates the following tasks. So first we have orchestration. Orchestration basically means bringing together of multiple applications and ensuring an order in which these are executed. So for example, if you consider a web page that you require to host, this web page stores all its values that it takes from the user into a database. So the first thing you must do is ensure that the system has a database manager, and only then do you host your web page. So this kind of an order is very crucial to ensure that things work right. Next, Ansible automates configuration management. So configuration management simply means that all the systems are maintained at a consistent desired state. Other tools that automate configuration management include Puppet and Chef. And finally, Ansible automates deployment. Deployment simply means the deploying of application onto your servers of different environments. So if you have to deploy an application on 10 systems with different environments, you don't have to manually do this anymore because Ansible automates it for you. In fact, Ansible can also ensure that these applications or the code are deployed at a certain time or after regular intervals. Now that we know what exactly Ansible is, let's look at Ansible's architecture. Ansible has two main components. You have the local machine and you have your node or the client machine. So the local machine is where the system administrator sits. He or she installs Ansible here. And on the other end, you have your node or the client systems. So in case of Ansible, there's no supporting software installed here. These are just the systems that require to be configured, and they are completely controlled by the local machine. At your local machine, you also have a module. A module is a collection of your configuration files. And in case of Ansible, these configuration files are called playbooks. Playbooks are written in YAML. YAML stands for YAML ain't a markup language. And it is honestly the easiest language to understand and learn since it's so close to English. We also have the inventory. The inventory is a file where you have all your nodes that require configuration mentioned. And based on the kind of configuration they require, they're also grouped together. So later in the demo, we'll have a look at how the playbook and the inventory is written, and that will probably make it clearer. So of course, the local machine needs to communicate with the client. And how is this done? This is done through SSH. SSH is your secure shell, which basically provides a protected communication in an unprotected environment. Okay, so we saw the various components of Ansible. Now, how does Ansible exactly work? You have your local machine on one end. This is where you install Ansible. If you have gone through any previous material on Ansible, you would have come across the term agentless often being associated with this tool. So this is what agentless means. You're installing Ansible only on your local machine and there's no supporting software or plugin being installed on your clients. This means that you have no agent on the other end. The local machine has complete control and hence the term agentless. Another term that you would come across with Ansible is push configuration. So since the local machine has complete control here, it pushes the playbooks onto the nodes and thus it's called a push configuration tool. Now the playbooks and the inventory are written at the local machine and the local machine connects with the nodes through the SSH client. This step here is optional but it's always recommended to do so. It's where the facts are collected. So facts are basically the current state of the node. Now all this is collected from the node and sent to the local machine. So when the playbook is executed, the task mentioned in the playbook is compared against the current status of the node and only the changes that are required to be made further are made. And once the playbooks are executed, your nodes are configured to the desired states. So as I mentioned before, Ansible is currently the most trending tool in the market under the configuration management umbrella. So let's have a look at the various benefits of Ansible which gives it this position. Well, Ansible is agentless, it's efficient, it's flexible, simple, idempotent, and provides automated reporting. How does it do all this? Let's have a look at that. Agentless, as I already mentioned before, you require no supporting software or plugin installed on your node or the client system. So the master has complete control. And automatically this means that Ansible is more efficient because now we have more space in our client and node systems for other resources and we can get Ansible up and running real quick. Ansible is also flexible. So an infrastructure is prone to change very often, and Ansible takes no amount of time to adjust to these changes. Ansible cannot get any simpler with your playbooks written in a language such as YAML, which is as close to English as you can possibly get. Idempotent basically means that if you have a playbook which needs to be run n number of systems, it would have the same effect on all of these systems without any side effect. And finally, we have automated reporting. So in case of Ansible, your playbook has a number of tasks and all these tasks are named. So whenever you run or execute your playbook, it gives a report on which tasks ran successfully, which failed, which clients were not reachable, and so on. All this information is very crucial when you're dealing with a very large infrastructure. And finally, we reach the most exciting part of our tutorial, the hands-on. Before we move on to the actual hands-on, let me just brief you through what exactly we'll be doing. So I'll be hosting 2 virtual boxes, both CentOS 7 operating systems. One would be my local machine and other my node or the client machine. So on my local machine, first I'll install Ansible. We'll then write the inventory and the playbook and then simply deploy this playbook. On the client machine, there's just one thing that we need to do is that we need to check if the configurations that we mentioned in our playbook are made right. So we'll now begin our demo. This is my Oracle VirtualBox. Here I have my master system, which is the local machine, and this is the client machine. So let's have a look at these 2 machines. This is my client machine. The terminal is open right now. So the client machine terminal has a black background with white text, and the master machine terminal has a white background with black text, just so you can differentiate between the 2. So we'll start at the master machine. The first thing to do is we need to install our Ansible. So yum install Ansible-y is the command to do so. So this might take some time. Yeah, so Ansible's installed. The next step, we go to our host file. So our host file here is basically the inventory. It's where you'll specify all your nodes. In our case, we just have one node. That's the path to your host file. As you'll see, everything here is commented. So just type in the group for your client nodes. So I'm going to name it Ansible Clients. And here we need to type the IP address of our client machine. So my client machine's IP address is 192.168.2.127. So before you come to this, it's advised that you check the IP address on your client machine. The simple command for that is ifconfig. Now once you type the IP address, put a space, and here we need to mention the username and the password for our client. So I'll be logging in as the root user. So this is the password. And then the user. Which is root in my case. That's it. Now you can save this file. Just clear the screen. Next, we move on to our playbook. We need to write the playbook. So the extension for our playbook is YML, which stands for YAML. And as you can see here, I have already written my playbook, but I'll just explain to you how this is done. So a YAML file always begins with 3 dashes. This indicates the start of your YAML file. Now the first thing is you need to give a name to the entire playbook. So I have named it sample book. Host is basically where this would be executed. So as we saw earlier in our inventory, I mentioned client's group name as Ansible Clients. So we use the same name here. The remote user is the user you'll be using at your client. So in my case, that's root. And become true is basically to indicate that you need to set your privileges at root. So that's called a privilege escalation. Now a playbook consists of tasks. So we have here 3 tasks. The first task, I've named it to install HTTPD. So what we are doing here is we are installing our HTTPD package, which is basically the Apache server. And we are installing the most latest version of it. Hence the state value is latest. The next task is running HTTPD. So for the service, the name is HTTPD because that's the service we need to start running and the state is started. Our next task is creating content. So this is the part where we are creating our web page. So copy, because this is the file that will be created at the client. The content will be welcome and the destination of the file will be var www.html index.html. As you know, this is like a default path that we use to store all our HTML files. Now, as you can see here, there's quite a lot of indentation. And when it comes to YAML, although it's very simple to write and very easy to read, the indentation is very crucial. So the first dash here represents the highest stage, that is the name of the playbook, and all the dashes under tasks are slightly shifted towards the right. So if you have 2 dashes at the same location, they basically mean that they are siblings. So the priority would be the same. So to ensure that all your tasks are coming under the tasks label, make sure they are not directly under name. So yeah, that's pretty much it. So when you write your YAML file, the language is pretty simple, very readable. Indentations absolutely necessary. Make sure all your spaces are correctly placed. We can now save this file. Next thing, we need to check if the syntax of our YAML file is absolutely right, because that's very crucial. So the command to check the syntax of the YAML file is Ansible playbook, the name of your playbook, syntax check. So we have no syntax errors, which is why the only output you receive is sample.yml, which is the name of your playbook. So our playbook is ready to be executed. The command to execute the playbook is Ansible playbook and the name of your playbook. So our playbook's executed. As you can see here, gathering facts, that's where all the facts of the node, that's the present state of the node, is collected and sent to the local machine. So it's basically to check that if the configuration changes that we are about to make is already made. So it's not made. We do not have the HTTPD package installed on our node. So this is the first change that's made. Also, if it's not installed, of course, it's not running. That's the second change that's made. So it's put into the running state. And a final task, which is create content, is under the OK state. This means that the content's already present in the client machine. So I made it this way so that you can at least see the different states that's present. So over here we have OK4, so 4 things are all fine. The facts are gathered, 2 things are changed, and 1 is already present. 2 changes are made. 0 clients are unreachable and 0 tasks have failed. So this is the documentation that I was referring to previously that Ansible provides automatically and is very useful, as you can see. So our next step, we need to just check on our client machine if all the changes that we desired are made. So let's move to our client. So this is my client machine. So to check this, since we are installing the HTTPD package and hosting a web page, the best way to do it is open your browser and type in localhost. So there you go. Your Apache server is installed and your web page is hosted.
Hi guys. In this video, we have compiled the most important interview questions of configuration management tools, Chef, Ansible, and Puppet that you might face in a DevOps interview. So without further ado, let's get started.
So let's just get into the first section, which is configuration management. So one of the questions that you'll get asked right away is, why do you have SSL certificates used for Chef? Really fundamentally, your immediate answer should be security. SSL provides for a very high level of private security and private and public key pairing. This really is essential to ensure that you have a secure environment throughout your entire network. The second part should be that if you're using SSL and you're using the private public key model within SSL, you're able to guarantee the systems on your network that the Chef, that you'll be able to validate that the nodes within your network that Chef is validating against actually are the real nodes themselves, not imposters. So you will also be asked some questions such as the following. Which of the following commands would you use to stop or disable the HTTP service when the system boots? And you'll typically get 4 responses, and there'll be hashtag systemctl disable httpd.service, or is it system disable http.service, system disable httpd, or the final option, which is systemctl disable httpd.service. Your answer should be the first one, which is hashtag systemctl disable http.service. So Chef comes with a series of tools that allow it to function effectively. And one of the tools that you're going to be asked about is, what is Test Kitchen? And Test Kitchen is essentially a command line tool that allows you to be able to test out your cookbook before you actually deploy it to a real node. So some of the commands that you would use are, for instance, if you want to create an instance of Test Kitchen, you would do kitchen create. If you want to destroy an instance after you created it, you do kitchen destroy. And if you want to be able to combine multiple instances, you would do kitchen converge. So a question you'll get is around Chef is, how does Chef Apply differ from Chef Client? So fundamentally, the difference between them is that Chef Apply will validate the recipe that you're working on, whereas Chef Client looks to apply and validate the entire cookbook that's run in your server environment. So one is focused on the recipe and the other is focused on the entire cookbook. So there are some differences when you're working with different command lines. So for instance, when you're working with Puppet and you're working with one version of Puppet and you want to do, what is the command to sign a requested certificate? The top example here is for Puppet version 2.7, whereas the lower option here is for Puppet version 3. And that's something to bear in mind when you're going through your interview process, is that the tools that are used within a continuous integration, continuous delivery DevOps model do vary. And so you want to be able to talk knowledgeably about the different versions of the tools so that when you're talking to your interviewer, you're able to show the deep knowledge that you have. Which open source or community tools do you use to make Puppet more powerful? And essentially this question is going to be asking you to look beyond the core foundation of Puppet itself. And so the 3 options you have is being able to track configurations with Jira, which you should be doing anyway, but it's a great way to be able to clearly communicate the work that's being done with Puppet. Version control can be extended with Git. And then the changes should be passed through Jenkins. So the 3 tools you want to be looking at: integration with Jira, Git, and Jenkins. So what are the resources in Puppet? Well, fundamentally, there are 4. The resources are a basic unit of any configuration management tool. They are the features of the nodes. They are the written catalog and the execution of the catalog on a node. So as we dig deeper into Puppet, one of the things that you are likely to be asked regarding Puppet is, what is a class in Puppet? And so a class in Puppet is really the name blocks in your manifest that contain the various configurations. And this can include services, files, and packages. And we have on the screen here an example of what a class would look like when you write it out. And you may want to memorize just one class. Don't memorize just a whole set of classes. Just memorize one. The person that's interviewing you is just really looking for someone who has a working knowledge. They're not looking for you to have memorized complete massive classes, but having one small class to be able to illustrate the experience you have is extremely valuable to the interviewer, particularly if it's a technical interview. So as we move into Ansible, one of the things that you're going to be asked around Ansible is, what is Ansible role? So a role is an independent block of tasks and variable files and templates embedded inside of the playbook. So the example we have here on the screen actually shows you one role within a playbook. And in this role, it is to install Tomcat on a node. Again, as with previous question within Puppet of a class, it's probably good to have memorized just one or two roles so you can talk knowledgeably about Ansible when you're having your interview. So when you're working with Ansible, when should you be using the curly brackets? And so just as a frame of reference, there's often two different ways that these kind of brackets are referred to. They're either referred to as French brackets or curly brackets. Either way, what you'll be wanting to ask is, when would you use these specific types of brackets within Ansible? And really, the answer comes down to two things. One is that it makes it easier to distinguish strings and undefined variables. And the second is for putting together conditional statements when you are actually using variables. And the example we have here is this prints the value of, and we have foo, and we have to then put in the variable conditional statement of foo is defined as something. So what is the best way to make content reusable and redistributable with Ansible? And there's really essentially three. The first is to include a submodule or another file in your playbook. The second is to import an improvement of an include, which ensures that a file is added only once. And then the third is roles to manage the tasks within the playbook. So a question you will be asked is, provide a differences between Ansible and Puppets. So if we look at Ansible, it's a very easy agentless installation. It's based on Python. You can configure it with YAML, and there are no support for Windows. In contrast, Puppet is an agent-based installation. It's written in Ruby. The configuration files are written in DSL, and it has support on all popular operating systems. So we dig deeper into the actual architecture. Ansible, it has a much more simple architecture, and it's definitely a push-only architecture. In contrast to Puppet, it's a more complicated but more sophisticated architecture where you're able to have a complete environment managed by the Puppet architecture.
And now with that, we have come to an end of this session. I hope it was informative and interesting. If you have any queries, do let us know in the comment section below, and our team of experts will be happy to resolve all your queries. Until next time, thank you, stay safe, and keep learning.